All right, so 8.1 is talking about geometric mean and how we're going to use that with right triangles. So geometric mean is between two numbers, so we're going to call them A and B right now. It's the positive square root, so only positive numbers. Typically, when we take the square root of something, you get a positive and a negative answer. We are strictly dealing in the positive here, so we are not talking about negative answers at all. So it is the positive square root of their product, or the positive square root of us multiplying those two numbers together. So let's look at an example. I have 8 and 4. So I'm going to say the square root of 8 times 4. Now there's a few ways you can go about doing this. You can go ahead and multiply these two together. 8 times 4 is 32. And then you can go through and factor it out. But I could also go ahead and factor these separately and see if I find any pairs, which is what I like to do so I don't have to deal with as big of numbers. So if I look at 8 and 4, I can split 8 down into 2 and 4. And looky there, we have a pair of 4s. And then I have a 2 by itself. So that pair of 4s is going to go outside, and then the box stays on the inside, so 2. So the geometric mean between 8 and 4 is 4 the square root of 2. That is our simplified answer. Let's take a look at another one. Now again, sometimes multiplying them together might be beneficial. This is one of those instances. So we're going to take the square root of 1/2 times 2. Well, 1/2 times 2 is 1, and the square root of 1 is just 1. So in this instance, our answer came out to be a whole number, and that's okay. So if you do see something that says simplify your answer, simplified radical, but you come up with a whole number, that's completely fine. Sometimes you will completely get rid of that square root, and that's great. Now, what does this mean for our right triangles? Well, we're going to use that geometric mean several times and find different missing sides of our triangles.